let's see this question. It says E1 and E2 are two ellipses whose center are at origin, and major axis of E1 and E2 lie along x-axis and y-axis respectively. We cannot do anything because we don't know anything about the ellipses, so we have to read more. Let S be the circle this. Okay, we know that. The straight line this touches the curves, the circle and the ellipses at P, Q, R respectively. Now enough information and we can start drawing what they are telling us. So where is the center of the circle given? 0 comma 1. Okay, so let's say here you have a point 0 comma 1. What's the radius? Root 2. Okay, root 2 is little more than here 1.4 around. So you can just complete the circle right now. What are they saying? So there is this line x plus y is equal to 3. You know how that line looks like. X and y intercepts both are 3 like this. Okay, let's say. So this is the point P, okay, which is tangent this. At that point, you have a tangent, okay. Then this line also touches E1 and E2. Okay, what is E1? It has major axis along x-axis. So let's try drawing ellipse which okay, so let us make it touch here. Okay, okay, I hope it looks like an ellipse for you. Okay, so this point, okay, they're saying is Q, where the line is touching this ellipse, E1. This is called, they are calling this E1. This is S. Now we have to also draw an ellipse E2, which has major axis along y-axis. So let's say it touches here. Okay, so this is the point. Then we have to go for a little thinner ellipse. Let's check this out. Okay, so this is the point R. Now what more? They are saying that PQ and PR are this numbers. Okay, so the distance they have given, that 2 root 3 by 2 root 2 by 3, and even this is 2 root 2 by 3. Now E1 and E2 are eccentricities of the two ellipses. Then which of the expression is correct? So basically they are looking for eccentricities of the ellipses. What do? We don't know anything about the ellipse, right? Just that it is at distance this from point P, the R and Q points. So what you have to do is we have to go ahead and try to figure out what are these points R and Q. Okay, for that what do you need? Of course you need to figure out what is that point P, right? Which is obvious how to get that point P, because you can independently write equation of tangent to the circle at any point. Let's say P is x1 y1. Can you write equation of the tangent at x1 y1? Open that up. Okay, you open the equation of the circle which they have given you. This is plus 1 is equal to 2, or you can write minus 1 is equal to 0. Equation of the circle given to you. Now write the point form of the tangent x1 plus y1. What happens to that? Y plus y1 minus 1 is equal to, that's the equation of a tangent. Let's try writing like this, so that coefficient of x and y are together. Coefficient of y is from here minus 1 also, and constants I will take on the other side. So these are the constants here. Why I'm doing this? Because I want to compare it with the given tangent. Okay, the tangent given to you is x plus y is equal to 3. Let's compare them because they are both giving the same equation. So if you compare them, you get x1 upon 1 is equal to y1 minus 1 upon 1 is equal to y1 plus 1 upon 3. Now solve this quickly. What do you get? Let's use these two first. Okay, so you get 3y1 minus 3 is equal to y1 plus 1. How much do you get? 2y1 is 4 or y1 is 2? You got y1 to be 2. Use these two. Okay, y1 is 2, so x1 is 2 minus 1. X1 is 1. So what is this? You got P point. Okay, P point is 1 comma 2. Okay, what next? I want to get my Q and R, remember? Okay, that's the only information you have. Okay, so what do? Can you get a point, okay, which is along this line at 2 root 2 by distance from P? Similar thing for the above one, right? A point which is at 2 root 2 by 3 distance from P, okay, along this line. Okay, how do you do that? Remember parametric form you're going to use. Okay, let me write parametric form. X minus x1 upon cos alpha. Okay, alpha is the inclination of that line. Tan alpha is the slope of this line basically, along which you are going to take the distance. Y minus y1 upon sine alpha is equal to, in our case it is plus or minus 2 root 2 by 3. This much distance. Now how do I know my cos alpha? Do I know tan alpha? Huh? Tan alpha is slope of this line, right? Okay, y is equal to minus x plus 3 you can write. So tan alpha is minus 1. Okay, so you can use your triangle. to get the numerical value of cos and sine. This is root 2. So what is your cos alpha? It will be negative, right? Because you're making obtuse angle, because tan alpha is negative. Okay, so cos alpha would be positive 1 by root 2, but sine alpha would be sorry, negative 1 by root 2, because you're forming obtuse angle again. Sine alpha will be positive 1 by root 2. Okay, because you know that in the second quadrant this is positive, but that is negative. Okay, so now let's go ahead and write the values. X1 is what? 1. Cos alpha we just now said is minus 1 by root 2 is equal to y minus y coordinate of p, and then this is 1 by root 2. This is plus or minus 2 root 2 by 3. We have to solve this. Okay, maybe I can multiply by or divide by root 2 throughout. Okay, let's do that. I'm getting minus 1 is equal to y minus 2 upon 1 is equal to, I'm dividing by root 2. Okay, so I'm getting 2 by 3. So with plus value, let's solve it for plus value. Okay, let's do it here. So you are getting x is equal to, if you take this plus value, okay, you get 1 minus, yeah, 1 minus 2 by 3, that's 1 by 3, right? Okay, the y value with the plus 1, what do you get? You will get y is equal to 2 plus 2 by 3, that's 8 by 3. Minus sign, what you are going to get? Use the minus sign, you get 1 plus 2 by 3. Okay, how much is that? 5 by 3. Value what you are going to get is 2 minus 2 by 3, that's 4 by 3. Okay, so you got the two coordinates. Okay, what is these coordinates? This is coordinate for r, and this is the coordinate for q. Okay, you can see that, right? So q coordinate you got is this 4 by 3, and r coordinate you got is 1 by 3 comma 8 by 3. What are you going to do next? You still need to know what are the eccentricities, right? Okay, so you have to work with the ellipses now. Let's start working with that. Now let's say the one ellipse E1 we are talking about. Okay, let's write equation of E1. E1 equation, let's assume it's x square upon a square plus y square upon b square. It's 1. Okay, why I'm writing? Because you know eccentricity, they're asking eccentricity. I know if major axis is along x axis, then eccentricity is minus 1 minus b square by a square. Okay. Now the only thing you know is the point Q, where your tangent is known to you is again this. So independently write equation of the tangent again, x1. Okay, x1 is what? 5 by 3. Okay, I'm going to write 5 by 3 here. Okay, if you don't mind, I will take that 3 down. Plus y1 I'm going to write 4 by 3 b square is equal to 1. What next? I'm going to compare. Okay, with what? Again, x plus y is equal to 3. That's the tangent, right? So now compare them up. Okay, compare. I'm going to write it here after comparing. So I'm getting 5 upon 3a square divided by 1. I don't write that. Is equal to 4 upon 3b square again divided by 1. I don't write. Is equal to 1 by 3. So what do I get? I get a square, right? What is a square? 5. What is b square? 3. Did we get even? Yeah. Okay, so you write 1 minus 4 by 5. That's 1 by 5. I got even square to be, let me highlight that, 1 by 5. This. Now, can I also get what is, let's write now equation of E2 ellipse. Okay, remember E2 is along, major axis is along y axis. So let me assume the same equation. Y square upon b square is 1. I hope you don't get confused with that. Okay, this is another ellipse. The only thing is this is major and this is minor. So what will be the eccentricity for that? 1 minus a square by b square, remember? Okay, now do exactly the same stuff. Write equation of tangent at this point now. Okay, so x1 I'm going to write 1 by 3 a square plus y1. What is y1? 8 upon 3. So 3b square is 1. Compare. Compare with what? X plus y is equal to 3. So much roll about this line, okay, all the time. So let's compare. I'm going to write it here. If I compare 1 upon 3a square by a 1, because the coefficient is 1 here, 8 upon 3b square upon again 1 is equal to 1 by 3. Okay, what do you get? You get a square to be 1 and b square to be 8. Nice. Okay, so what is your e2 square here? 1 minus 1 by 8. So what do you get? 7 by 8. Done. Okay, you got e1 square to be 1 by 5 and e2 square to be 7 by 8. Okay, now let's start checking here. So e1 square plus e2 square is what they're asking here. Okay, so just now we got e1 square to be 1 by 5 and e2 square to be 7 by 8. Let's add them up. 40 This is 8 plus 35. So you get 43 upon 40. Check. Correct. Okay. This one is correct. Do the product even e2 and check. 1 by, okay, it's under root you have to take. Okay. It's e1, not e1 square. So root 7 upon root 8. That's root 7 over root 40. And 4 you can take out. That becomes a 2. So 2 root 10. This is also correct, right? This is not correct because if that is correct, this can't be. Okay. So this is not correct. C part, just check C part. E1 square minus E2 square. Okay, just now we said E1 square is 1 by 5 and E2 square is 7 by 8. Okay, what are you getting? This is 4, this is 8 minus 35. How much is this? 27 over 40. So we are getting this value to be 27 over 40. So this is not true. Understood? Okay, nice question, right? See you with another one.